Okay, today I will talk on how we can use AI in Industry 5.0, which is one of the important cornerstone of 6G technology. So let me start with the main motivation behind Industrial Revolution, and then I will go on the Industry 5. So if you can see that in 1784, when we start our first industry revolution, which we call Industry 1, where the main target was to do electrical power kind of things to improve our industry and our mechanical part of the areas which we want to, especially with the hand powers and factories, etc. And then when after 100 years, we start using steam engine, water power to work with the factories. This era is mostly dominated by the mechanical human forces and human power. And then after again 100 years of time, we enter into the era which is mostly dominated by the IT, start doing IT and kind of small intelligent in the network, but not fully incorporated. So in this era, we actually putting a step toward a real artificial intelligence, which is you can see from today and tomorrow. So here, computers, IT, and system, we start entering into the our factory areas, and then we enter into the industry 4, which we are now, where it's not fully autonomous, but we try to make it autonomous in the next decade, and we have a lot of smart things, IoT, big data, machine learning, and that is where we are now. But the big question is that now we are we will going to be enter into industry 5. Still it's not available, and here the main difference is that this is fully cyber physical cognitive system, which is more or less coming from our human brain, from the neural sciences. How our human brain will react, we need to translate same intelligent to the machine. So if you can divide this picture into two parts, the era which is on my right hand side, which is fully automated, we are going toward automated, and there are pre-IT or pre-AI era, which is industry 1 and industry 2. So now we mostly talk in the industry 5, but it's very important to understand what is the difference between industry 4 and industry 5. The major difference is that industry 5, we have cyber physical cognitive system, kind of human brain, and we want this intelligent to be translated into the machines. So if you put that vision of industry 5.0, so it's very important that this industry 5.0 can affect our society. That concept you cannot see in industry 4.4 or backward. This is where there's a big difference between industry 5 from industry 4. We have the industry revolution, fourth revolution, where we have a lot of IoT, big data, artificial robot, sharing economics. But the main goal of industry 5 is to make society more comfortable and sustainable. And it's also called our society 5, because we directly map from industry 5 to society 5, and this kind of a very super smart society which you can see in industry 4 revolution. That is the main motivation, and this society can have a cyber cognitive capabilities which they can convert these abilities to be to the machines. So the keyword is the society 5, which is going to be mapped with industry 5.0. So you can see the basic difference between in this slide, the industry 4 and industry 5. If you talk in the labor part, In the labor part, industry 4 is mostly in the machine or a human. So it's kind of or relationship. But here, this is kind of a and relationship where you human with the machine. And similarly with the system, if you talk in the system, you have a cyber physical system on the industry 4, but in the industry 5, we have cognitive cyber physical system. And product and services, industry 4 targeted target group, like a crowd sensing kind of things, which is a group, and they give on average quality of experience and quality of service to that group. But here the main goal is to give the kind of this individual personalized experience, because we are moving towards society 5, where our socialism activities are quite important. In the supply chain in the industry 4 deal with the data analytic, and in industry 5 you can see it's a responsible and distributed kind of network, because here the main goal is to individual personalized experience. And in the lastly, the networking, they are mostly IoT connected devices, which you can see a lot in industry 4. But here our main goal is to experience a quality of experience of each individual industry 5. So you can see the big difference between industry 4 and industry 5, but from my side, the biggest is the system level, where you have a cognitive cyber physical system, which is really dominant from our human behavior, and we need to translate toward this to the machine. So now the question is that we need to translate that part to our society. So if you divide, human society is divided into 4 parts. In first society, when we born in this world, our main mission is to eat and to survive. For that, we are killing animals and we to survive. At that time, there is no social behavior, because everyone want to survive. Then after times passes by, then we enter into urgent kind of society, where we start living into small towns, and moreover we are not only emphasizing on the food, but we also start living into family town and start cultivating different agricultures, product, fruit and wheat. And this is the era when the humans start to realize that, okay, we have to think beyond the eating. We need to build our society, our cities, towns. And then we enter into society 3, which I call more or less industry 4 kind of industry 3, where you more or less you use mechanical part, steam engines, and humans start realizing that, okay, we have to more socialize ourselves. This is a society which is quite important. And after that, we enter into society 4, which is we are now in industry 5 4.0, which is now is most tech society, and which you can see that we use a lot of information technology, ICT kind of things to the work analysis. So this phase starting from industry society 1 to society 4, and now the next phase we entering into now is society 5. So if you can see that the main goal of society 5, that we have to live comfortable and sustainable as a people, and to use the products which we already involved in industry 4.0, but now it's more smarter and sustainable. So we use a lot of big data, because we deploy sensors everywhere, information technologies are coming, we do kind of smart processing on data, and make our life much better if you compare with the society 4.0. This is my vision toward AI and how we map this to the societal behavior, because that is where we are going. So on the x-axis, you can see this is the efficiency of intelligence, and on the y-axis is the complexity. If you said that I divided this into pre-AI era, this is the era when we start with our society, when we are almost for the food and we don't have any concept about socialism. So that is the era between divide with society 1 and society 2. And if you do start by 1980, when our first artificial intelligence from computer sciences came into the picture and we're using machine learning. So that is the era where till now we are using part of that. The communication part will be divided into 1G to 5G, and our industrial will be 1 to 4th generation. We are now revolution, and this you can divide into society 4.3 to 4.0. And then you have a 25 from next 2 year. It's kind of human in a loop kind of thing, where you can take the intelligence not only from the machine, but also from the human combined together and make your system much better. And that is the era when we enter into Industry 5, and this from the communication perspective, that is 6G, and from the society is 5.0. And from, if you go into next 20 years, I believe we go into the real intelligent. A real intelligent means that your machines are always more or less equal than the human being, and they at least senses like taste, feel, touch, write, listen kind of senses they are able, not all of them, but at least few of the senses of 5 out of 5 they start to understand your machines. And that is the era when you have Industry 6, 7 and 7G and society 6. And then 60 years from now on, we human intelligent, and when your machine is almost like a human intelligent. But again, this is more superficial, but I don't know. But this is a vision that our machines will be like a human intelligent, and you are entering to 7 to 8G, a 7 to 8 industrial revolution, and communication around 9G, and you enter into society 7. And of course, the next century is the off limit, what I call, that is machines are more capable than the human. Like for example, nowadays we create machines which are much better than a human being. Like human eyes cannot go beyond 500 megapixel, but you can have a camera which go beyond that. So this off-limit intelligence can possible, but again, this is the time. Still, we have a lot of time when you enter into 9, and I don't know how this society 8.0 look like. But if you compare by now, and you can imagine, this will be very, very smart and super high tech factory. So this is my vision about AI and how you map with different communication and this industrial revolution. So why we need Industry 5.0? Because of following feature, they can reduce the cost, empower the worker, and also attractive the best talent in competitive industry, adopting a new skill, improve our safety and well-being and competitive edge in the market. So mostly in the summary, the Industry 5, the solution provider for the people, for our planet Earth, where we are living by using all these bullets, which I just mentioned. So let's also talk some of the communication part, how we started. So if you see on the x-axis, you can see after every 10 years, our communication generation is changing, which is faster than this industrial revolution, because communication part is faster than the part. So if you see, these are devalued, and if you see this color, this is the valued. If you start in the beginning, 1980s, when we have human machine interface, have very less devalued, because on that time we don't have keyboard, we don't have mouse, so a lot of operating system and hardware get a bit valued. But ARPANET network, ARPANET started in States and is coming to our civil lives in 1980s. This is the network which we are using on that time. so they get a lot of devalued. And then after every 10 years, we have to come with a new generation because our use cases are changing. And now our APRNet is changing into WW now. And this is a time when our start using internet and these getting valued, and also human machine getting also valued because of the mouse and keyboard. A lot of human machine interfaces are coming into pictures. Then this is a part when our telco systems, now the lot of operators are realizing now, okay, we have to use internet in our system. So this is the first time when China, Habai on that time, and I think Vodafone also, they start putting in their system, the telecommunication, the internet, in the core part to connect to the network. And on that first time, you can see 3G was there. So this is a Nokia 3310, very nice phone. And you can see that the human machine get less valued in that time, and hardware getting valued as well. And then after 20 years, we enter into the 5G era, and you can see that now our telco system now convert into the web of clouds. So a lot of operators now deploying a lot of cloud services, either owned by or from third parties. And you have a network, and you can see all the bottom boxes are get a lot of value. Now in 30, when you into the 6G part, when you have industry 5 there, so what happened in the communication domain? So web of clouds now converting into data centers. So a lot of data center will be deployed with very high servers, and they are running by application. Our DSPs are running there. So network get a lot of value because a lot of data centers are deployed. So that is like a passive device now for us. And virtualization will happen. A lot of virtualization. We don't use so much hardware, and hardware is just a RF part because baseband processing will be run inside cloud. And then we have a human machine interface will be holographic kind of things. So that is what you can see in 6G. So the most important part here is that we start with the APRNet. Now we end up in 6G with the data center. So in the future, you can see this is convert to the quantum kind of computing, where, but not now, it take more time, but we are heading toward that direction. You can see the speed is going very fast. And similarly with the human machine, we are almost like holographic kind of interface, which you can see in the Samsung new phones in 1928. Next 5 years, they are deploying that interface. Okay, I think, I don't know. Okay, and toward that direction, it's also important the complexity of the devices which we have. If we start in the beginning, we have very high phone, which very big transistor of 13 nanometer or 14 nanometer, very high. And then as the time passes by, our transistor size getting smaller and complexity will get more and more, and it's more power hungry if you go from our left to the right side. Now we are here where you have Samsung phone, and Huawei also have this touch adjuster, your foldable phone. But in the future, you can see tactile kind of gesture. But if you go from left, right to the left, your complexity will be less, but it's very, very nice battery consumption. And the very important thing to note here that you can see the transistor size getting smaller and smaller. Here we are using around 4 nanometer or 5 nanometer of transistor. So we cannot decrease more than that. This is what Moore's law tell us. So in future, we go to the photonic kind of things. So we don't need transistors in our chipset. We use mostly light devices, emitting devices, which can very small density. But this is just a picture which you can see that the complexity and the functionalities which we have now. So in the 6G, in the 5G till 1G to 5G, we develop solution either for the base station or either for the UE, because we have only 2 nodes in the network. We are either looking at downlink side or we are looking at the uplink side. So things are mostly fixed and partially dynamic when we enter into the 5G era. But what happened in the 6G, we are not only looking at 2 nodes for us, base station and mobile is not the only node in the network. In the 6G, we have a lot of other use cases. It is not finalized yet, but from the academic perspective, if you can read a lot of paper, we have two different worlds. One is a real world, one is a virtual world. In the real world, we have a lot of use cases. We have our verticals, we have different industries, we have automobile, we have human, we have sensors, and then we have another word which is called metaverse. It's a big word. Then the metaverse, you have the digital twin, you have AR, VR. So we need to optimize both worlds, not only the real world, but also the virtual world. The complexity will be a lot, but again, the benefit will be also a lot here. But here, everything will be dynamic. Only the speed of the light is fixed because that is coming the way our electromagnetic waves are moving and from the physics. So here we need to optimize the two world, which is the quite big challenge. And you can see here a lot of virtualization will happen. We use a lot of machines which help us to virtualize things. So why we use machine? Because machine can do a lot of things which human cannot do because of our physical ability, the way we born. So for example, we cannot audible bit above 200 2000 hertz, but we can have a machine which can go beyond that as well. Let me go faster because I think I covered the time. So with the with AI tool, so if you can see that from 1948 till 2020, we are using a very simple sequential model of communication started from the Shannon till now, and a lot of work have been done on the transmitter side, on the channel side, receiver, decoding, modeling, receiving. So a lot of work have been done. This is a model which we are using till 2020, but in the 2020, we also start working on the machine learning and taking the concept from computer sciences and try to put that concept in the communication world. And that is, you can see in the next future that how we can use machine learning in our network. So a lot of work already done on the upper layers application transport network, but it's quite challenging how to use machine learning at the physical and the MAC layer. If you see the protocol stack of our communication domain, mostly on the bit level and the symbol level. So the main idea is that we don't need to go to destination. It's just parents and son relationship that you need to learn from your parent. And once you are efficient enough, you break this connection and make their own decision. So that's how machine learning works. But the main challenge, how to implement that part at the bit and the symbol level. So these are some of the key application area where you can use back to the industry. You can use in the health sector, you can use in the supply chain, cloud manufacturing, disaster management, smart education, and manufacturing. These are few of them, but of course they have a lot application as well. So some of the key enabling technologies for the industry 5, which we need to work on it, so it become a reality for the future system. So this is quite a lot, so I will not go through all of them. So just imagine if we pick the communication part to connect our this industry. So 6G is quite important because that we are going. So for that, we need a good kind of knowledge discovery of all the devices around us. We need a smart resource management because a lot of thousands of devices, and we need a smart resource management at MAC layer or the upper layer, depend upon the use cases. And most important is the low latency, ultra high reliability. So in the 5G, there's a use case called URLCC, the third use case. But in the 6G, this can be wide because latency and reliability are two different KPIs, so we cannot combine together. But in the 5G, they combine, but the 6G should be a different because there are two different KPIs which we need to fulfill. And the most important, how to decrease the latency, is quite challenging in both parts. Either you talk in the industrial domain or in the communication. Latency is quite important. And then you have other bullet also digital twin, etc. So some of the example where you can use a use case example where Industry 5.0 is quite important. One first is the digital twin. You can make the twin of anything. For example, you can make the twin of your human organ. You can make the twin of process, or you can make the twin of the product. So in the first part, we need to take the physical entity. Then we need to extract the feature. This is a very high level. So, and you extract the feature. For example, in the organ, you need to a feature which you want to twin is like stress sensitivity, dynamic behavior, and then you have a communication part, which can be 5G or 6G, which communicate between two worlds. And then you need to have a virtual domain, which you can translate your physical domain to the virtual domain, and exactly with the same mapping, you create a virtual entity as well. And there is a sensors are data, which 24/7 data are coming, and you can create your virtual space, and then your specific value added service, whatever you want to do. So this is one of the very important use case, the digital twin. And this is a sub use case of your metaverse, which is a big picture, which you will see in future a lot. And also the healthcare industry. So we have a lot of elderly people in Europe. So one of the things which is affect a lot to how to the healthcare effect. So if you can see that before the industry 5.0, our patient need to go to the pharmacy, testing center, hospital, but after you deploying the vision of 5.0, everything will be on your one screen. You can see it, your sensor data is coming. Sensor data directly go to your doctor, and doctor can prescribe whatever you need, your testing and thing, and you don't need to go for testing as well. I will show you the next slide, and everything will be in the one screen, and thanks to Industry 5 use cases. And then same thing happen in the elderly. Nowadays they need to go to take the bus, go to the pharmacy, testing center. This is what's happening nowadays. But when you deploy the 5G, you kind of autonomous. You have autonomous driving taxis which have pre-planned route, and then you have drones, unarmed vehicles which can take your medicine from all the way to the hospital and deliver to your home. And same thing happen with your testing center. So that is in terms of the mobility use case. And in the infrastructure, more or less started in 5G, but still is not fully autonomous when you have worker, and we have a public infrastructure deployed in Europe where there is a lot of economics growth, but again we have not so much skilled labors. So that you can see that after deploying the Industry 5, you can see there is mostly sensors, and sensors are more AI kind of rated robots, so they can easily help to our society 5.0, because it's a fully automated society. And also the fintech is I don't know if you heard about that. This is one of the booming area for the future, where you don't need to stay in the banks to take a sleep and make account. You can do everything online. So fintech is started a lot in Europe. So this is also related to Industry 5, the banking sector, where you can use blockchain kind of technologies, and you use APIs and connect fintech banks with your communication network. So this is in future, you can just do the transaction, opening account without banks. So mostly the banks now convert into the virtual banks. So very few have a physical premises available. So they are now be fully virtualized, and other transaction will be secure with the cashless. You use just a card for the transformation of your money. So there are a few of the challenges which we need to solve. Some of the potential which you can use along with the other, which I just mentioned in the previous slide. You can have a digital drugs, smart factories, green ecosystem, smart fashions, intelligent traffic, innovation, and COVID, which we are passing nowadays. These are the high potential where you can implement your 5 industry. And Then you have some challenges. To make that possible, we need to solve some challenges. We need a more skilled workforce. We need human robot co-working, stability. The regulatory compliance is quite important. We have to the rules and regulations, so all the factories follow the same protocols and other stuff to make their products. And for the future, we have the quantum computing. As I explained you, this is where we are heading in the 7th or 8th G block, more advanced blockchain analysis, continuous training, and human machine cooperation as for the future direction.